We have spent 3 videos on vectors, single rows of numbers with direction and magnitude. Now we step up one level. A matrix is a vector of vectors. It is a table of numbers where every row is a vector. That simple structure is how AI stores entire datasets, encodes every neural network layer, and enables GPU parallelism. And you're already using matrices whether you know it or not. Your training dataset is a matrix. The weight layer in your neural network is a matrix. Every batch you pass through the forward pass is a matrix. Let us nail the vocabulary first, because these terms appear in every NumPy error and PyTorch doc. A matrix has rows and columns. Shape is always rows first, then columns. 2, 3 means 2 rows and 3 columns. You index with 2 coordinates, row first, column second, both starting at 0. A, 0, 1 is row 0, column 1. 3 special matrices worth memorizing. The identity, diagonal ones, everything else 0, is the matrix equivalent of multiplying by 1. Diagonal matrices scale each dimension independently, and square matrices, equal rows and columns, appear constantly in weight matrices and covariance matrices. In NumPy, creating a matrix is NP, array of a list of lists. Always check shape immediately. NDIM for a matrix is 2. For special matrices, NP. Zeros, NP. Ones, NP.I for identity, NP. Random, INDN for normal random values. The critical operations are slicing. A1 gives the entire second row. A2 gives the entire third column. The colon means all. The transpose, AT, swaps rows and columns, so shape 2, 3 becomes 3, 2. Open Jupyter and practice these now. They appear in every AI project you will ever build. Before we do operations, understand what each axis is actually storing. Training dataset. Row I is your ITH example, column J is its JTH feature. Shape, N_samples, N_features. Weight matrix. Row I contains every weight connecting all inputs to the ITH output neuron. Embedding table. Row I is the vector for word I. Looking up a word is just indexing a row. Time series data. Row T is a snapshot of every metric at timestamp T. Your Zabbix 24-hour monitoring data is a 1440/20 matrix. Once you know what the axes represent, the matrix operations in Video 8 will make complete intuitive sense. 3 structural reasons every AI framework is built around matrices. First, hardware parallelism. GPUs are designed specifically to multiply matrices in parallel. A single matmul executes billions of operations simultaneously. This is why deep learning scaled. Second, batch processing. Stack n training examples into a matrix, process all n in one forward pass. That is what batch size means, the number of rows in your input matrix. Third, compact transformations. Any linear transformation is a matrix multiply. A dense layer is a matrix multiply. The entire forward pass of a neural network is a chain of matrix multiplications with non-linearities between them. That is all it is. Key takeaway: a matrix is a vector of vectors. Its shape, rows, cols, is the first thing you check, every time. In nearly every AI context, rows index observations and columns index features. The exercises: create a 3, 4 matrix in NumPy, slice row 2 and column 1, transpose it. Then for a weight matrix of shape 128, 784, say out loud what each row represents and what each column represents. If you can answer that confidently, you understand matrices, not just the syntax. You now have the vocabulary and the mental model. You know what shape means, how to slice any matrix, and why GPUs are built for exactly this operation. Video 8 is matrix multiplication, and that is where everything comes together. The forward pass of a neural network is literally a chain of matrix multiplications. It is the most important operation in all of deep learning, and we are going to build the intuition step by step with full visual diagrams. Subscribe so it is waiting for you. Drop a comment with the shape of the biggest matrix in your own project right now.